A two-stage air conditioner is more efficient than a single-stage one. Single-stage units run at off or 100% capacity. Two-stage air conditioners run at off, 70%, and 100% capacity. So you can probably imagine that the two-stage AC can save energy usage by about 30% because the majority of the time, two-stage air conditioning units operate in first stage. But how can we tell if the two-stage compressor is running correctly? That's what we're going to talk about here on Fox Family Heating and Air. By only using part of the scroll, energy usage goes down because the motor that turns the shaft isn't working as hard since it's not pumping as much gas as it would in 100% mode. Testing a two-stage compressor is the same as you would with a single-stage compressor. The only difference is a compressor solenoid that sends the signal to the compressor to switch from first stage to second stage and vice versa. An energized compressor solenoid sends the compressor into second stage or the loaded position. Otherwise, it defaults into the unloaded position in first stage if it's not energized. In this video, we want to figure out if the two-stage compressor can switch between first and second stages. After turning on the AC at the thermostat, you can manipulate the call for first and second stage at the AC. The low voltage wires coming from the furnace inside tell the compressor to be in first stage or second stage. You usually have a common wire, a Y1, and a Y2 wire that connects to the same low voltage wires from the AC. Tying Y2 to an energized system that is only calling for single stage, Y1, can force it into second stage. With a call for first stage, go ahead and set your meter to amps and record the reading on the black common wire from the compressor. Keeping your meter there, switch to second stage by adding the unit's Y2 wire to the Y1 connection and record your amp draws there. It should be about 25 to 30% higher than the first stage reading. For example, if your first stage amp draw is 7.4, second stage should read about 10 amps, and that would be normal if the RLA of the AC is anywhere between 15 and 17 amps. If the amp draw is increased, the compressor is successfully loaded into second stage. Remove the Y2 wires from the connection to Y1, and the system should fall back into first stage. The amp draws will pretty much go back to the same amperage it was the first time you read it. If this process doesn't work the way it should, let's just make sure that the voltage is getting to the proper spot, the compressor solenoid. In most systems, there's a little black rectifier on the side wall of the service panel. It has 4 terminals. 2 of them are wires that lead to the compressor solenoid. The other 2 are connected to the call for second stage cooling or the Y2 wire connection. At the rectifier, set your meter to DC voltage and measure between the 2 white wires, and you should get about 15 to 27 volts DC with 24 volts AC applied to the rectifier. If you have 24 volts to the rectifier but don't have DC voltage leading to the compressor solenoid, replace the rectifier chip. If you do have proper DC voltage at the base of the white wires at the rectifier, but the compressor solenoid is not switching the unit to second stage, either the compressor solenoid is bad or the compressor's internal parts are failing. In this situation, you're going to have to replace the compressor. There's not a lot of info out there on troubleshooting two-stage compressors, so hopefully this will help you navigate through the process of determining if the compressor itself is bad or if it's something upstream of it. If this is your first time watching our channel, please click subscribe down here on the bottom right, and if you click that little bell next to it, you'll be notified of all of our videos as they come out. Thanks so much for watching, and we'll see you on the next video.